Hello everyone, welcome to this video. I am Vaishnavi B.Sc, studying in B.Sc second year in Adarsh College, Hingoli. Here in this video, I am going to discuss with you examples on the convergence of improper integral. Before moving on the examples, let us know what is the improper integral. Improper integral is every except possibly at an infinite number of points. A function f defined in an closed interval a comma b. Discontinuity is possible at left hand, right hand and both hand. Let us move on. Let us coming on the examples. Example number 1. Examine the convergence of integration of 1 by x square from 0 to 1. Let us come on the solution. Zero is the only point of infinite discontinuity. Therefore, integration of 1 by x square from 0 to 1 is equal to limit of integration of 1 by x square from lambda to 1 when lambda tends to 0 is equals to limit of minus 1 by x from upper limit 1 to lower limit lambda when lambda tends to 0 is equals to, we put upper limit minus lower limit of minus 1 plus 1 by lambda when lambda tends to 0 is equals to infinity. We get the infinite value, thus the improper integral is divergent. Let us move on. Question number 2. Examine the convergence of integration of 1 by under root of 1 minus x from 0 to 1. Let us see solution. 1 is the only point of finite discontinuity. Here in this question, infinite discontinuity is at left hand, right hand. Thus, integration of 1 by under root of 1 minus x from 0 to 1 is equals to limit of integration of 1 by under root of 1 minus x from 0 to 1 minus mu when mu tends to 0 is equals to limit of minus 2 into under root of 1 minus x from upper limit 1 minus mu to lower limit 0 when mu tends to 0 is equals to limit of minus 2 into square bracket under root of 1 minus mu minus under root of 1 minus 0 when mu tends to 0 is equals to minus 2 into limit of under root of mu minus 1 when mu tends to 0. We get the value is 2. We get a finite value, thus the improper integral is convergent. Let us move on the example number 3. Examine the convergence of integration of 1 by 2x minus x square from 0 to 2. Let us see solution. Both point 0 and 2 are points of infinite discontinuity of the given function. Here in this example, infinite discontinuity is at both ends. Therefore, integration of 1 by 2x minus x square from 0 to 2 is equals to integration of 1 by x into 2 minus x from 0 to 1 plus integration of 2 into 2 divided by x into 2 minus x from 1 to 2 is equals to limit of integration of 1 by x into 2 minus x from lambda to 1 when lambda tends to 0 plus limit of integration of 1 by x into 2 minus x from 1 to 2 minus mu when mu tends to 0. Therefore, by taking partial differential equation, we get the following equation. Integration of 1 by x into 2 minus x is equal to integration of 1 by 2 by x plus 1 by 2 minus x is equals to 1 by 2 log x minus 1 by 2 log 2 minus x log under root of x minus log of under root of 2 minus x log of under root of x by under root of 2 minus x. Therefore, integration of 1 by 2x minus x square from 0 to 2 is equal to limit of log of under root of x by under root of 2 minus x from upper limit 1 to lower limit lambda when lambda tends to 0 plus limit of log of under root x by under root of 2 minus x from upper limit 2 minus mu to 1 when mu tends to 0 is equals to limit of lambda log of 1 by 1 minus log of under root of lambda by under root of 2 minus lambda when lambda tends to 0 plus limit of log of under root 2 minus mu minus log of under root mu when mu tends to 0 is equals to, we get a infinite value. Thus, the given integral is divergent. Thank you for watching this video.